Okay, so today we are going to be finding inverses of log and exponential equations. And we're also going to be practicing graphing inverses. So remember, to find the inverse of anything, we switch our x and our y values, and then we solve. So for our first problem, we have f of x, which we know is the same thing as y, is equal to 6 raised to the x plus 2. So we have to switch that x and that y. So that f of x becomes x, and that 6 to the y, 6 to the x becomes 6 to the y. So now we have to go through the steps to solve. So in order to solve here, we have to take and get rid of that positive 2. So we subtract 2 from both sides. So we have x minus 2 is equal to 6 raised to the y. Okay, so anytime, again, we're trying to solve for the variable up in the exponent, we want to change it to log form. So we can see our base here is 6. So we're going to take log base 6 of our x minus 2 is equal to y. So again, remember, the 6 and the y were on the same side of the equal sign before. When we change it to log form, that 6 and the y go on opposite sides of the equal sign. So all we need to do here is leave our answer as log base 6 of x minus 2 is equal to, it started with f of x, so we just write it as f inverse of x. And that is our final answer for finding the inverse of that equation. Okay, so over here we have a g of x is equal to log base 12 of x minus 4. So this one is in log form, so we need to go ahead and again switch our x and our y and then change it to exponential form. So that g of x becomes our x is equal to log base 12 of y minus 4. So again, changing to exponential form, what is our base here? Our base is 12. So we take 12, we raise it to the x, and we set it equal to that y minus 4. So take a second just to make sure you're okay with how to change from log to exponential form again. Now remember, our job is to solve for y. So what do we have to do? We have to go ahead and add our 4 to both sides. So now we just have our 12 to the x plus 4. And again, instead of it equaling y, it was originally g of x, so we write it as equal to g inverse of x to note that it is the inverse function. Okay, over here, we have h of x is equal to 7 raised to the x plus 1 minus 4. So we're going to switch that x and that y. So h of x becomes x is equal to 7 raised to the y plus 1 minus 4. Now we go through the steps to solve for that y. So the first thing we have to do is we have to isolate that 7 raised to the y plus 1, and we do that by getting rid of that negative 4 by adding 4. So we have x plus 4 is equal to our base of 7 raised to the y plus 1. So it's in exponential form, and we are trying to solve for what is in the exponent, so we change it to log form. So our base again was 7, so log base 7 of our x plus 4 is equal to what we're trying to solve for, y plus 1. So we have to get that y alone. How do we get that y alone? We subtract 1 from both sides. So we're going to go ahead and just leave it as that log base 7 of x minus 4, of x plus 4 minus 1 is equal to, it originally started as h of x, so we write it as the h inverse of x. Okay, and our last example of finding the inverse when it's in log or exponential form we have p of x is equal to log base 4 of x minus 1 plus 2. So again, first steps, we switch our x and our y. So that p of x becomes x. Then we have the log base 4 of that x becomes y minus 1 plus 2. So we have to go ahead and get rid of that plus 2 first. And we're going to do that by subtracting 2 to both sides. So x minus 2, we just leave as x minus 2, is equal to the log base 4 of y minus 1. In log form, change to exponential form in order to solve for that y. So what is our base? Our base is 4. So 4 raised to that x minus 2 is equal to y minus 1. So now we have to solve for y. What do we do? If we have y minus 1, we get rid of that minus 1 by adding 1 to both sides. So we leave that 4 raised to the x minus 2 plus 1 is equal to, it was originally p of x, so we change it to the p inverse of x. And that is our inverse function there. Last thing you're going to be asked to do is to graph inverses. So just like when you're doing it algebraically, you switch your x and your y, you do the exact same thing graphically. So switch x and y. So for our first point, I'll go ahead and use some color here. We have the point -2, -3. So the inverse, x and y switch spots, -3, -2. So if we go ahead and plot that, so our original point was right here at -2 and -3. And our inverse is at -3 and -2 right there. Our next point, we have -1 and 0. So -1 and 0 is right here. So in order to get to the inverse, we just switch those, 0, -1. 0, -1 is here. Our next point, we have 1 and 2. You switch those around, it'd be 2 and 1. So 1 on your x and 2 on your y as you here. And the inverse 2 and 1, 1, 2, and 1 is here. Next up, we have the point 3 and 4. Switch x and y, it becomes 4 and 3. So the point 3 and 4 is here. The point 4 and 3 is here. Okay, now we have the next point, which is 6 and 5. Flip them, we'll make it 5 and 6. So 6, 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5. And flip it around, 5, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 6. Okay, so here are 9, 6, and 6, 9. They don't fit on our graph, so we're not going to worry about those. Again, you're just switching your x and your y. So just a few things if we look at this graph a little closer here. So we had our original line was right here through these points. Our inverse function is a mirror image over a line of symmetry. This line of symmetry is always at y equals x. Okay, so the graph's a little ugly, sorry, but you can see that it's a reflection over this line y equals x. And that is all for your notes for today.